population ecology. And this probably is one of the hardest sections of ecology for most people, just because there's a lot of graphs and analyzing graphs. So let's just redefine what a population is. We've talked about it before, but it's the individuals of a species that interact with each other. And they can interact in positive ways and in negative ways. Mostly, usually in a population, you're going to interact in positive ways. You're going to, do things like mate and help each other and all those kinds of things with one another. Okay? And there's different ways to look at a population or population characteristics that you might see. Ways to describe populations. So one of them is you can describe it by its density. And density is just the number of individuals per unit of area. So it could be like 30, here's an example, bison in a square mile. Okay? So it's just a way to describe how many are in that area. Another way that you can define a population or a population characteristic is you can look at its size or how big it is. It's just the total number of individuals. So it could be like there are 4,000 bison in America, and so that would be the size of it. Okay. This down here is what's called an age structure graph, and it's a way to look at a population, and it shows how it basically, we're going to write about it on the other side there. It shows the number of individuals of each age group in a population. So you can see like there are about 5% that are under 5 that are males, and 5% that are under 5 in this population for females, 5 years old. And then from the 5-year-old to 9-year-old, there's a little bit less than 5%, and so on and so forth. Okay. So let's just kind of write what this age structure graph is all about. So it's called an age structure. You see them really commonly when describing human populations. It shows the number of individuals of each age group. Okay. And what you see, like this population right here is a growing population. Notice it kind of takes on this triangular shape. So this is what we can write this down at the bottom, a growing population, okay? If you were to see an age structure graph that looks like this is an upside down triangle, and that takes on that shape, it is what you would see as a shrinking population. Now, you might want to write down more information than I'm writing down, because there's a lot to write down about this, or a lot of information. If you see a square type population, this is what the United States is actually, you would see a stable, okay? It's not really growing and it's not really shrinking, it's just kind of staying the same. So you have a very stable population. Other ways that you can describe a population or other characteristics of a population is you can look at its density and how those organisms are dispersed within their density, okay? And so what we mean by density is the density and the way the changes is the density, or how many are in a given area, tells a lot of information about that population. If there's food there, if there's water there, they're going to maybe congregate near water, so you might have a bigger density near there, or a food source, or maybe there's a good area for protection from predators, so you can get a lot of information. And changes in that density, if you were studying like, hey, there was 50 individuals in this area 2 years ago and now there's none, it'll tell you changes, tell a lot of information about abiotic influences. So maybe why is there no more individuals? Maybe it's because there was a drought in that section, so they had to move on, or there was a big flood and so there's no grasses there, or whatever, okay, the case may be. So this information, looking at your density and looking at changes in the density, tells a lot of information, okay? Then organisms can be dispersed in different ways. You sometimes see what's called a clumped pattern. So if you were looking like as an aerial shot at a group of individuals and you were to map them, and you saw that all the individuals were clumped up. They were all kind of like this in your population. Like think of a school of fish, for example, okay? It's an indicator of cooperation in that population. They're going to work together to do something, to avoid a predator, to get food, something, okay? Think of an example of that would be like a school of fish, has a clumped dispersion pattern. If you have a uniform dispersion pattern, that means again, same aerial shot kind of thing. If you have like very uniform, very even distribution within your pattern, that is an indicator of those species in that population established territories, and they probably defend their territories, okay? So they have a very uniform or very even distribution pattern. A lot of the big cats, like mountain lions around here, actually have this type of pattern. And then the last one is random. It's like nothing. There's no pattern. There's no rhyme or reason. They're just whatever. They're wherever. A lot of plants that are like wind dispersed are like this because it's just random, okay? It's usually in plants. And really the other thing about a random dispersion pattern is that there's really no influence. There's no competition or cooperation or anything like that. Okay, there's nothing influencing that pattern of dispersion. A couple other things that we're going to define, and then we'll get into some of the real characteristics of growth in a population, how a population can grow, is something called life history. So a life history is it's the time for growth, development, reproduction, and death. So let me give you an example of what we mean by this. In humans, it takes about, let's say about 13 years to grow big enough to develop, okay, in order to be able to reproduce. And then you carry your baby for about 9 months. And then the body continues to develop and get older and older and older until the death pattern, it's about 75 years or so. Okay, so that's a life history of someone that lives in the United States. Okay, if you have a really short period to grow and you can develop really quickly, and then your reproduction time is really short, you're probably also going to die pretty quickly. So there's like the fruit flies, they have like a 12-day life history. Everything happens within 12 days. So fecundity kind of comes out of this, and it's what this word means. It's the average number of offspring that each individual produces at each stage. Okay? Usually, like, each individual is going to produce, like you would say, like a blue whale, it produces one offspring every 2 years. Okay, that would be their fecundity. So it takes a long time for that population to grow at that rate. Okay, this idea of resources and allocation, there's a really, really good picture in your book of this. So make sure you take a look at that idea and that concept. But basically what happens is organisms, throughout their life, that's really their job, or food. Okay, when we talk about resources, we're really talking about food. And so whether they're making it themselves or they're getting it from something, and they must allocate or divide up the resources to do these things. You ready for them? These things, okay? Priority 1 in your life is to maintain homeostasis. If your body can do nothing else, it's going to just try and maintain homeostasis. Priority 2 is it's going to defend itself. So if you don't have enough resources to maintain homeostasis, you're not going to be able to defend yourself. Priority 3 is you're going to try and grow. So if you're good at maintaining homeostasis, you have a safe environment, you're going to try and grow. And then if you can do all of these things and still have leftover resources, you're going to allocate the rest of your resources for reproduction. Okay? So that's kind of the priority order and what your body's trying to do with all this food or resources that it gets. Now, if you have enough for reproduction, if the population has enough resources, then they get to grow. And there's two growth models. And on this side, this model, where it just, within a few hours, this is the example of bacteria. We'll put an example bacteria down here. Within a few hours, the population has exploded or grown exponentially, okay? So this is what they call multiplicative, because it multiplies, or exponential growth. Exponential is probably the more common one. Your book uses the other term, so I just want you to recognize it. This is known as R growth. Okay, I'm not sure why the R. It's the rate of growth, I think. The other one is additive or logistic growth. Okay, what happens in this one? These are known as K growth. This is K growth or K strategy. Okay, is what happens in this one is they'll grow for a little bit. They'll grow actually exponentially, but then they level off and they reach what's called, this line here is K, or it stands for super annoying carrying capacity. It's annoying because it doesn't start with the same letter. We will look at this in class, so hopefully it makes sense then. So what ends up happening, let's look at if you are an R selected species or